Right, guys, we'll just pick up from the last problem which I've done in the last video. That is like development of surfaces 2. Now I'm just moving on to the cylinder problem. Since you have done enough of prism problems and pyramid problems, we'll just move on to the cylinders problem in the development of surfaces. Alright, please go through the question here. It's a cylinder of base 50, diameter axis 70 mm long, resting with its base on HP. Axis 35 mm in front of VP is cut by an auxiliary inclined plane whose trace is making an angle 45 degree to HP. I think we have covered this thing, so I'm just quickly rolling off. Right, and this is your section. I'm just like putting it with a section red line, so just so that you guys will have. Right, so this is your section making 45 degree to the HP or to the XY line. Okay, now this is 15 mm from the top base 15 mm. Right, now let us find out in how many points this section is cutting the solid in. Okay, this would basically give us the developments. All right, now before that, like, we want to develop out the surface. The surface will be developed out to basically 2 pi r or pi d. From here till here, this is pi d. It's like developed out. Now I've divided my circle into, I'm just moving sliding this a little bit upwards just so that you can have a better visual here. Right, now this is my XY line, and you have your cylinder's front view projection. This is my front view projection. I have my A dash and G dash. That these are the basically the two extreme ends. Like, this is my A's projection A dash, G's projection G dash. Similarly, I have, like, this is my front view I'm seeing from here. Right, so I can basically see all this section till A till G, like all these lines will be seen as solid lines. Okay, since I don't have a long edge unlike the prisms, I'm basically creating some edges using my generators. Okay, all my generators, I've divided this circle into 12 equal parts, right, using one of those methods I taught in class. So you guys can divide that into 12 parts just for a nice smooth curve when we develop out. All right, now this is like my B, so I'm just like naming that B dash, C dash, D dash, E dash, F dash. G dash is already here, H dash, I dash, J dash, K dash, L dash. Okay, these are the ones in braces, so these things are not seen. I'm seeing from here, like, these are all the ones, like from H till L, all these are put in braces. Okay, so now let us do the development here. So I've divided this part into, like, this is my outline. So this outline I can blindly draw it with the, I'm just putting solid lines here. This is my outline spread out. This is the development of the cylinder. Okay, cylinder has been developed out. This is length is like 2 pi r or pi d, pi into d, diameter of this circle, and then into pi is whatever this spread is. So this is like an arc length. Okay, this is an arc length, and this is the linear length spread out. So you have an r theta, like if r into theta would be giving you the linear length of this small chunk. The same concept is used here to develop it out. Now let me get the points, like, you know, where it's cutting the, sorry. So here, this is like my number one says these are 12 parts, and then lateral surface I have 12 parts, but how many points is cutting in is what's important for us. So this is my number one solid line, number two solid line, 3, 4, 5. Since it's cutting the base, like 2 points, like one here and one on the other side, 6 on the other side, right, 7 on the other side, 8 on the other side, 9 on the other side. This is basically cutting in 9 points, right? Now let me just get the division of this one. Like, this is like I'm approximately dividing this chunk into 3 equal parts. Similarly this one into 3, similarly this one into 3, right? Similarly this one into 3. So this will basically give me, so I'll just quickly draw the lines for you here. So this is basically the development of the cylinder. I'm assuming that I've divided that circle into 12 parts and I have 12 generators. This is what I'm assuming. So starting off from here, I'm developing it, opening it from here basically. So this is my A, B, C, D. I'm using capital letters here. Okay, H, I, K, L, and A. Okay, the last point again. A starts and A ends. Similarly, if you want to start B here, it will end with B as well, because it's a circle. It's a cyclic thing, right? Now, pretty simple. Now that I have all the 12 parts divisions here, now this would be basically like on bottom I can say A1, B1, C1, D1, E1, F1, H1, 1, J1, K1, L1 and A1 again, right? Now pretty simple. Now all you have to do is just drop these lines here. One is on the A line, right? So straight away I'll just take this point from 1. I'll just draw here. 1 is here, number 1, and 1 here as well, right? So I'll just use a red pen here, and 1 and 1, right? First step. Now 2 and 9. 2 is on B line and 9 is on L line. Okay, so straight away I'll just move this onto B line and L line. Okay, so if I'm drawing the line like this here, right, this is my point here and here. This is my point 2, this is my point 9. Now let me go to the third point. Third point is on the C line, and the 8th point is on, what is this, K line. Okay, K line. So this is my K line and this is my C line, my point 3, and this is my point 8. Pretty simple, like 3 and 8 falling on C and K line. If you want to draw the parallel line, this is like how you draw the parallel line. Pretty simple, right? Now 4 is on D line, 7 is on J line. So I'll just move on to the D line and the J line respectively. My D line and this is my J line. So I am marking the points on the J line and the D line. The point on the D is 4 and this is on 7. Similarly, I have my 5 and 6. Where is my 5 and 6? 5 is on the E right here, and then 6 is on the I. Okay, so this is on the top base. So this is my 5, and then this is on the other side I. This is my 6. Right, now if I cut this, like now all I have to do is just join these points, right? Now since it's a circular surface, unlike the prisms, this one has a circular surface. So I'm not drawing a straight line here. I'm not using a ruler to draw the straight join 1 and 2 points. I need to use a small curve. Okay, so 1 point at a time. So between 2 points, just try to draw the curve. This is also the same thing. Okay, just join it out, form a curve. This of course, when it's developed out, this will look like a straight line, and this is a straight line also. But this curved surface is basically a curved surface. It should look like a nice curve, nice smooth curve, which is cut out from a cylinder, right? And this is also straight line. So this also has to be drawn red line, since we are just developing this whole surface here. Okay, this is the development of the surface of the bottom part. So this part is what we are developing out. This other part, this part is gone. So this part from here till here, from 5 to 6, and then this remaining part E to I, like this chunk is remaining here, and then the bottom, like this whole of the base is there, and then from here 1 till 1. So this is your development of the surface of the cylinder which was cut out. So please note this down. Also you guys can take a screenshot or whatever, like you can note down the question. Yeah, I'll just move it a little bit right here. So you have the question there and the solution here. So that should be it for you guys. So cylinders, pretty easy, right? So the one thing which you have to remember is when it's cutting the base, obviously even if it's cylinders or prisms, if it's cutting the base, or even pyramids, if it's cutting the pyramid base, so it will basically cut in 2 points. Even if it's cone, the same thing, right? So remember this point. Now let's move on to the next question. The last one for today. We'll just wind it up here.